Great. Thank you so much, Candice, for that introduction. A very good evening to everyone here in India. A very good morning to those in the States. And thank you so much for joining in, taking some time out as I take this opportunity to emphasize on this journey that we have from open source to open sovereignty. And more specifically, what is it that we can do as a community when it comes to building development pipelines while ensuring all practices with respect to sovereignty compliance are taken into account. So diving right in, the way I've sort of structured today's session is to set some context about the mission statement. I wouldn't call it a problem statement, I'd call it a mission statement, and then how it ultimately bifurcates into a technological problem that we have to solve, and then what's really the path ahead for all of us. Uh, Diving right in, it is very important to understand that we do have a paradox at hand. If you look at software development altogether and the journey that has sort of taken place over the last 25, 30 years, a lot of infrastructure optimization, a lot of software optimization has been about making sure as much of your storage is close to compute, right? And most of the optimizations that we see with system design and with infrastructure tend to solve this problem, right? How can we drop latency? How can we increase the performance of our system overall by making sure that compute and storage are as close to each other as possible? Up until now, software development and coding, I would say, as a glossary statement, did not really fall under consideration when it came to this, right? Because it was an isolated activity performed by engineers, and once quote unquote, we were done coding and we were done building an application, we would ship this application to our infrastructure, and that's where all the optimizations took place. But code now development now is becoming just as much an infrastructure problem, right? It's not just an isolated activity anymore. It's just as much an infrastructure problem. And this is because quite a lot, if not all of the code that we're producing today, all of the high quality code that we produce today is generated. And therefore, it becomes paramount that you start considering where your code is being generated. Because if we were to continue optimizing along the same tangents, which is to bring compute and storage as close to each other as possible within the confines of principles of computer science and engineering, what are we doing today to make sure that the code that we generate is as close to us as possible? In the process of solving this as an optimization problem, there are several other things to consider, right? One of the key aspects to consider is when you are generating code, what's really happening behind the scenes? Uh, when you select a part of your code and you're essentially sending it for analysis or to generate documentation, what's really going on behind the scenes, right? And how much is an organization answerable to questions about that aspect? How much of our IP is going over via API calls when it comes to code generation? We're really relying on tools we don't control. We don't really have visibility. There is a sense of opaqueness. There is a black box. And some operational constraints that come with that is, we really have no control over rate limits and throttles. We don't really know how much or how little we can use a tool. And what are we doing with respect to our sovereignty is a big question that, we really don't have an answer to. So there is a productivity and privacy paradox. There is also a sense of motivation that engineering has followed about, how are we bringing storage and compute as close to each other as possible, but with code generation, we are just at that stage where at the cusp of beginning to take that into account. And that is an important piece of context that I think we need to set before we move out and solve this problem. The second is what are we doing as a country or as a nation altogether? What are we doing to make sure that we solve this problem, right? And India is a very, very large contributor of open source. Uh, what is the effort that we're putting in to make sure that while we're contributing to open source, uh, how much of it can we leverage to gain control over our products and applications? There are several governments all over the world that are now beginning to take this aspect very seriously. The aspect of how much control we have over our data, over our pipelines, over our operations and our technology. And India very recently has begun taking into account the DPDP Act, right, which requires you to be answerable for every aspect of how you generate code, how you maintain your applications, of any personally identifiable information that might exist in your data. And when quite a lot of this code, or when quite a lot of these applications are being generated by opaque black box models that are really outside our control, when these compliances kick in and you are to be answerable for the applications you develop, how are you going to be answerable if you don't really know what's going on behind the scenes? And that's really the mission statement, right? That's the context that I'm trying to set. And sovereignty is a safeguard, is a mechanism to regain control. It is a tool for the paranoid. It is a mechanism for us to make sure that when we are building solutions of national importance, of private importance, of organizational importance, we have more things in our control so that when things aren't going right or when compliances kick in, we have the capability to make sure that we can make necessary rectifications and proceed. And finally, when you take into account the paradox that we spoke about, and therefore, making sure that we're optimizing in the right direction, you take into account what we just discussed about, full control. How do we ultimately take these two things into account and build the right kind of tools, right? Because for your tool or for your application to be truly sovereign, you need to make sure that you're hosting it, controlling it, right, within your country, within infrastructure that is in your control. Uh, an important aspect over here could be, how ephemeral is your entire application, all right? So how much of it is really retained, and how much of it becomes a vulnerability after a certain point in time, and it becomes more and more baggage for you to carry. But with, let's say, a sense of an ephemeral solution, you could basically not worry about that because there's a sense of statelessness to your solution, right? So we need to move towards a charter or set out a charter that has no black boxes, that gives you more control. There is a sense of transparency, and there is a sense of ease when it comes to working with compliances and guidelines. Here in India, that could be the DPDP Act and the Ministry of Electronics and Information Technologies guidelines that they prescribe. So as we take that step towards getting more control in terms of our data, our tech, and our operations, uh, open source and sovereignty really help because they are the essential arsenal you need to keep afloat in this climate. With this context, I'd like to dive deep into what we've done at NextGen in terms of building a truly sovereign coding assistant. And it's what we call M for coding. And what lessons did we learn while we were on this journey of building an application ground up that is truly sovereign and enables developers to take that next leap? The general distribution of this journey is about infrastructure. It's about the model landscape. It's about how we looked and solved the inferencing problem. And then finally, when all of this is set, what agents can we leverage really to bring this to life and to offer to consumers, to enterprises, and all of our customers? And then a little bit about what are the considerations that you need to take into account when you're pricing solutions like this. Step one for any application is always infrastructure. NextGen has been doing cloud and has been running data centers for the last 12 years. And I would say one of the benefits that me and my team experienced when we were working on M for coding in terms of building a truly sovereign solution was the fact that infrastructure for us was a solved problem, right? And when we talk about infrastructure, it's to do with everything really, from the bottom up, the servers that come into your data center, power, networking, and storage, the orchestration mechanism, so the entire virtualization layer, and then finally beyond that, handing off to developers for them to consume or for them to run their applications. Now, with the advent of artificial intelligence, that dynamic changes a little bit. There are a few more considerations for us because when we're looking at infrastructure, infrastructure is now very different when it comes to running probably a training workload and an inferencing workload in the world of generative AI. Inferencing workloads are more to do with running these large language models in a very optimized manner across different GPUs or different nodes, and making sure that you can match certain SLAs in terms of performance, right? How long do we take to produce a token? How long do we take in between tokens? And altogether, how long do we take for an end-to-end result for our customer? When it comes to training, the considerations are slightly different. Training is more of an isolated activity that you would want to do a few times. It's not a perpetual solution. And with training, the bigger consideration over here is how quickly can you really move checkpoints around when you're in between epochs and you're, sort of writing to a file system. And therefore, the consideration there is because GPUs are pretty quick, your bottleneck becomes storage. So what are we doing in terms of properly networking our machines so that they can share checkpoints across really quickly? And, if I were to draw parallel to the hierarchy of memory, how effectively are we using our high bandwidth memory, our cache, and then our file system and storage, right? So all of these become important aspects to consider. Uh, when it comes to coding, when it comes to the problem that we're trying to solve, it's purely an inference problem for us to solve. And therefore, I will try to confine this webinar to mostly talk about optimizations in that regard. But beyond that, when you sort of architected or set a charter for what kind of problem statement you're solving, training or inference, this is where all the exciting stuff now comes in, and this is the accelerators of choice. There's been a lot of noise around NVIDIA and the amazing work that they're doing with their accelerators. So we're working with some of the best accelerators at NextGen, the H100s, the H200s, the L40Ss, and eventually the B200s as well. And it becomes paramount for you to take accelerators into account because these are ultimately performing the floating point operations per second that give you an output. The two broad considerations, even with the other accelerators, the AMD MI325X or the Intel Gaudi 3, and what we get from IBM with the AIU Spire, and quite a lot of the other accelerators in the space that do inference. I think the two things that you really need to take into account are how much high bandwidth memory do you have available, and what teraflops figures your accelerator is giving you, because you need to be essentially pushing out as many tokens per second or maintain as high a throughput as possible. And also, you need to basically make sure that your accelerator in isolation is able to store a very large model in its high bandwidth memory. And that becomes a very important consideration in this space. And finally, I think once you're done taking a look at your accelerator, your overall architecture for spreading out your servers, that's where orchestration comes into place. And this is where we work very closely with Red Hat. Um, and our orchestrator of choice is OpenShift. But this is really what's responsible for giving your infrastructure all the bells and whistles you need for rapid development and rapid prototyping, right? And our developers, our teams internally, are a recipient of the outputs of OpenShift, right? So if I were to say this bluntly, AI engineering altogether or application development altogether might not really be concerned about all the layers below, but they would be into the mix right from the point where infrastructure is orchestrated for them to leverage. And beyond this, and we'll touch on this in a little bit, is where we're looking at different inferencing mechanisms finally on top of these machines that help us sort of leverage these models in the form of API endpoints, right? So infrastructure becomes a very important consideration. You need to look at this entire stack bottom up, and it's safe to assume that necessary set of optimizations on each layer will help you maximize the value you get right on the top. The second thing, and this is probably the most intuitive aspect when it comes to building a sovereign agent, is really the set of models that we use, right? And it's slightly more challenging than you think it is because you think that you want to take the best model in terms of benchmarks right out of the bat, and go on its face value, deploy it, try it out. But it is much more complicated than that. I think the first thing that you take into account is what are you really trying to achieve with your model, right? Because if I am doing a coding agent, the downstream functionality that I want to achieve via a coding agent is significantly different from uh, probably a RAG or probably an agent that is summarizing or creating tickets agentically. The nature of the task is very, very important. And the problem with the nature of the task is it's not really a quantitative value that you can measure. It is a qualitative aspect, and a lot of intuition comes into play. You need to get the right experts in the room for them to take that into account. And really, that's what I'm trying to highlight over here. It might make sense for you to use an instruct model, a dense model for a task that revolves around summarization, classification, and probably translation. But when it comes to maybe reasoning tasks, when it comes to tool calling, that's where you start taking into account mixture of experts or chain of thought, family of models. And that's really the second point. When we look at the sort of MOE suite, the mixture of expert models that are present in this climate, you have great models right now with the DeepSeek R1, with the Kimi K2, and very recently the Kimi K2 Thinking, and Quen as well, the family of models from Quen, doing a ridiculously good job and giving you much better outputs, I would say, when it comes to the kind of problem statement that we're trying to solve. Dense models would essentially, are not really optimized for tool calling and would really leverage all layers across the transformer to give you an output. Whereas in reality, you could have a significantly smaller expert sitting on a GPU somewhere, giving you that output in much quicker time with much higher accuracy. So off late, it's become more or less a no-brainer that you pick a MOE against a dense model. But 2024, the same time last year, probably a very different consideration. So safe to assume that this climate will keep changing in terms of what architecture is powering the model. You need to take into account the quality of the model as well. What is its capability in terms of completing tasks? And this is where quite a lot of these well-renowned open benchmarks really help. So SWE bench, terminal bench, and a few of the others that I mentioned here play a key role, right? You want to be sure that when the model runs on your infrastructure, you're able to reproduce the same results that the model family or the manufacturer of the model is publishing on their Hugging Face page. So even though you have these numbers available on GitHub or on Hugging Face, it would be an essential exercise for you to take the model, run it on your own infrastructure, and run the benchmarks and see what scores you're really getting. If not anything, it tells you that you might be deploying it in an incorrect way, especially with these MOE models. The mechanisms to deploy and enable function calling is something that you really have to consider. I think another very key aspect is, and this probably is relevant more so to NextGen than to the developer community, but when you're building a product like this, you might want to take into account the optimizations that model manufacturers do on specific hardware. So let's say we talk about NVIDIA's suite. NVIDIA has, let's say, a model like the Nemotron might happen to work significantly better, might be further optimized to run on NVIDIA's infrastructure. And you might want to take advantage of that model OEM co-optimization, wherein a model has been optimized to run on a specific kind of accelerator. And therefore, I think a simple way to draw a parallel is if you're able to see that a model has been trained on a certain GPU and the blueprints for that specific model have been published on a specific accelerator, more often than not, I think you'd get a very linear experience running inference for that model on the same accelerator. And it's important to sort of take that into account as well when you're architecting a solution like this. And then very key aspect over here is the context window. What's really the context window that your model supports? And it is, again, a very important thing because how much information you're able to put into a single request via a coding agent is directly dependent on the context window that you set. But one of the key aspects is, beyond just how much you're able to give to the model is if you're setting too large a context window, the concurrency you can support drops. And I'd like to take the discussion about concurrency on the next slide. Inferencing is significantly different from leveraging the weights of a model, right? So we could get the weights from Hugging Face, but how optimized is your inferencing? And what I mean by that is how effectively are we leveraging our accelerator when it is perhaps serving inference on these models for us? We all know that at the end of the day, we want to consume these models as probably OpenAI API compatible endpoints, right? As an API endpoint. And the journey to take a model from its weights to an API endpoint is generally powered by an inferencing engine like VLLM, TRTLLM, there's SGLang, there's TGI, there's a whole lot of options here. And it is paramount again for you to take into account, which inferencing engine you use and what are the figures you're able to get in terms of benchmarks when using a specific inferencing engine. And then obviously you have NVIDIA NIMs that is I would say, an amalgamation of what you get from VLLM, TRTLM, and NSG-LAN. The second thing here, when it comes to high performance inferencing, is the parallelism techniques that you take into account. When we look at a node, it is generally 8 cards or 8 GPUs, right? And if I'm talking about a model that is about 40 GB, I could fit the model on an individual card and maintain copies of that model, a little bit like a redundant array. You could think of it like that. I would maintain copy of the model on different cards, and I'd call that data parallelism. But with mixture of expert models, a smarter thing to do is to split the experts across different cards, and that's what we call expert parallelism. And the problem gets only more complex because you would need to sort of now take into account the fact that you could have one expert sitting on a node, a part of another cluster somewhere else, and you could have one expert sitting on another cluster. And it is your responsibility to make sure that they are able to communicate with each other without taking too much time or without introducing too much latency. So parallelism techniques are definitely the future and are a very key aspect to solve when you're running models on your own infrastructure and as you take that step towards sovereignty. And again, the benchmarks that we do for high performance inferencing are slightly different from the benchmarks we just spoke about on the previous slide. Here, I'm more interested in the time that my entire experience takes, the time to first token, the inter-token latency, the end-to-end latency, and how many tokens I can produce per second. So these are some things that I want to take into account. And now this is again like very, very purpose specific to what we're trying to solve. Coding specific inference, and I touched on this slightly earlier, coding specific inference is very different from general purpose inference, right? Because you're putting in your coding files. So this could be Python files or Rust files going in, and then you have about 20,000, 30,000 tokens going in, and your model is supposedly supposed to give out probably 3 or 4 thousand tokens to respond to that. So it is a heavy use case in comparison to general purpose chatbots like we do, let's say, with the likes of ChatGPT or Perplexity. We're putting in fewer tokens in and we're expecting fewer tokens out. So it becomes important to look at your deployment strategy and your model inferencing capability from that perspective, that you have very high input sequence tokens and very high output tokens as well. Once we're done taking into account the accelerators and the models and the inferencing engine, now we look at the final downstream application that my users will use, right? And when we look at the open source space over here, we have great options with Klein, with RuCode. These are, your VS Code extensions. Uh, Quite a lot of you might have used Cursor, again, a brilliant VS Code extension. And then we also have terminal experiences with Aider and with Claude Code. Some of you might be using Claude Code. But we really want to filter out from this entire universal set of agents, which agent is supporting an aspect of sovereignty, right? How effectively can you take the source code, customize it under, obviously under proper licenses, and make sure that it fits to your use case. So when you're looking at the family of coding agents, we need to take into account, and I've sort of tried to highlight that, how many of them have compatibility for taking in an OpenAI compatible API endpoint, which essentially is running on your own infrastructure. Consideration one. The second is how effective is the tool really, right? One of the earlier tools in this space was Continued or Dev. Back when it came out, it really did well with summarization, with document creation, and it helped a little bit with generating snippets of code within files. But we've seen that coding agents have evolved significantly from that point on and have now evolved into more an autonomous experience wherein they're really doing everything for you. So we're looking for that. We're looking for tools that can automatically do your Git commits for you, that can automatically leverage a MCP for file IO. So it's doing your ls, cd, mkdir, rmrf commands for you automatically. And it is automatically able to detect its own flaws, rectify them. We're looking for that truly autonomous experience. So you need to further filter out from the options that you have in terms of what's helping you achieve that. And the next thing is, when you look at a tool, All of these tools are generally a mixture of very nicely written prompts. You might have seen a few of these prompt banks on GitHub as well. All of them are a mixture of not just these tools, but also very nicely written prompts that help you achieve that, experience, right? And these prompts are ultimately what will go to your deployment, your model. It becomes very important for you to look at the prompt bank over here as well. Again, we're not trying to modify anything. We're not trying to, add value to this layer, but at the end of the day, a good prompt, right? And I've tried to highlight that over here. A good prompt is going to save you a lot of inferencing. It's going to save you a lot of reruns and a lot of queries that would repeatedly go into the system and ultimately impact your economics, right? So efficiency economics are driven heavily by prompt, and not a lot of people are giving due credit to a good prompt versus a bad prompt because it's tough to quantify that difference. But it's very important to take that into account, right? And therefore, with good agentic capabilities, with a good prompt bank, with the right tool, you would be able to find a very good combination that sits on top of your infrastructure and your model suite. And that's really what we're going after. Another small consideration is depending upon your organization or depending upon the community that you're targeting, it is important for you to pick between a terminal experience and extension-based experience. Terminal experience is very critical for people who would be writing a lot of their code within virtual machines. So all that they have access to is their terminal, and probably VS Code like extensions are better for full stack developers, application developers that aren't really responsible for taking that code and shipping it to a virtual machine. So maybe where a DevOps team is involved, it might make sense to leverage a VS Code extension versus wherein you have full stack system engineers that are generating code. You might want to have a terminal experience for that. And therefore, putting it all together, when you try to solve pricing for such a product, it's everything that we've spoken about so far, right? You need to take into account the infrastructure, the GPUs, the accelerators that you use. What is the cost that you bear when you are running inference for models on top of them? How large is your model? Because how large your model is will determine how many GPUs you need. And then, how effectively have you networked your infrastructure for inference, right? Because if I'm doing expert parallelism and I'm trying to use two or three nodes, two or three separate isolated nodes for inference, it becomes very important for me to consider how they are exchanging information between each other. And then beyond that, what are the average user behavior? What is the average user behavior when it comes to using coding agents, right? So when I want to solve a problem, as a software developer, I might be putting in 3 to 4 queries to solve a problem. But then, in another organization, probably we're putting in 10 to 15 queries or maybe just one query, right? So user behavior is driving economics. And again, that becomes an exercise that you need to run within your organization. And it's a simple exercise that you need to run within your organization to really crack the code and get that secret sauce. A big advantage with having this kind of full control end to end is you have full visibility on the pricing, right? I've spoken about quite a lot of things and quite a lot of considerations, but once you've really done that exercise, like we've done at NextGen, uh, I now know exactly how much it costs to run an inference for every single developer within the team, within the entire organization. And that form of visibility really just does not come with these endpoints that you're probably trying to consume, these black boxed environments that really exist in this space. Uh, it only comes when you have that form of full control over the entire deployment. And this is sort of circling back to the point I was trying to make in the beginning, wherein a solution like this, while there are a lot of reasons to push for a sovereign solution, one of the added benefits is visibility in terms of how much cost you're going to bear when you run a solution like this. And it's safe to assume that it's significantly more economical to do something like this, to run a sovereign solution for as few as maybe 15 or 20 developers, right? It starts to get significantly cheaper than API endpoints, wherein again, you're suffering from a different set of problems, right? Problems around compliance, problems around rate limits and throttles. None of those exist here. And really, to put it all together, there are some great things happening in open source, and it is getting ridiculously easy for all of us to build great solutions with open source models. we are achieving great performance parity. If you're looking at what Kimi K2 thinking just benchmarked, I think last week, it's doing so much better than quite a lot of the proprietary models in the space. But even if you put benchmarks aside, these models are capable of doing everything that you really need to do in the landscape of coding. We have a customer that wanted to do COBOL, and that's already solved with these open source models. So I think it becomes important to focus on what problem statements you're really trying to solve. The difference between a Quen coder, a Kimi K2, a DeepSeek R1, or a Claude code does not matter if your primary use case is probably mean or MERN stack or full stack development, because these have been solved for a while now, right? So it becomes important to acknowledge that we've achieved that performance parity with proprietary models. The models are there for you to use, and you really could just go out there today, right after this session, and you have access to such brilliant, well trained models, and their blueprints that have been used to train them are available for you to leverage as well. So all the information is out there in open source. You have brilliant IDEs, sort of coding agents that sit within IDEs for you to leverage. One of which is M for coding. It's live, and we'll be sharing the link with all of you shortly as well. And you could really leverage this at 9 rupees an hour, which is you know a ridiculously good cost for the value that you could get for it. And all of this runs in India on sovereign infrastructure. So it's safe to assume that we've done this exercise. Whatever I've spoken to you about is actually done, it's solved, and could be done significantly better by any one of you on this call, right? There's no real limitation over here, and it's all available for us to leverage and use. Uh, so that's I think an amazing aspect to highlight. And beyond what, coding agents and optimizations and the technology in itself, beyond all of these things, we're now setting up rightly for protecting IPs, for being compliant with whatever our government wants us to do with respect to, let's say, DPDP, with respect to, let's say, HAP filtering, PII, personally identifiable information. We are creating the ideal environment to be, fitting in such a compliant heavy setup, which the world will be eventually when we move towards sovereign. Uh, I think that a lot of this comes down to academia, right? So how much research is going to be happening in open source? Really, it's the birth. It sort of births this entire experience for us, and therefore, what we're doing at NextGen is we're partnering with a lot of startups, with a lot of government ministries, with a lot of academia as well. The likes of the IITs, the IISCs in the country. We're working with everyone really to make sure that we are playing our role in accelerating that journey. And this could be in terms of making models available for our customers, building end-to-end solutions on open source, making M for coding as a product accessible to teams that are working in very, very IP sensitive environments. So we're trying to play our role here. But really, it comes down to all of us doing it together as a community and leveraging this opportunity that we have in terms of taking it forward. And I think agility, autonomy, and accountability are really the best three words to sort of put all of this into motion. Uh, Sovereignty is it's not just a thing to talk about. It's not just a cool thing that the world is headed towards. It is genuinely, I think, one of the most important considerations if you're valuing the product that you're building and the longevity of the product that you have at hand, how independently the product can run. All of these things really depend on how sovereign your solution is. And therefore, in conclusion, the path forward is really the tech stack's complete. I touched on that just on the previous slide. We have everything that we need to start doing great things. We have economics that work, and we are in early days. If you're still able to optimize and sort of come down to a number that is digestible by India as a country or the world as an economy, it becomes a great hypothesis that data privacy and cost effectiveness can really coexist. It's nothing that we have to go out of the way for. Uh, all of us are really champions for this use case. Uh, Coding was heavily procedural from the start, and generative AI was the ideal accelerator to make sure that we're able to do more in the same time. And therefore, the developer community is I think the most paramount, plays the most important role in making this push towards sovereignty when it comes to running solutions on your own infrastructure, running your own models, and running your own applications altogether, fully in your control. And therefore, the movement ahead I think the charter ahead, I think is very clear. You try to get your hands dirty with what you have available, and as time goes by, you are either contributing to some of the latest and greatest in the space, or you are taking advantage of the brilliant advancements that are going to happen in the world of open source. And make no mistake, there's going to be some of the best things lined up ahead when it comes to artificial intelligence in this space. So I think my mission statement is, let's code for speed, sovereignty, and then a self-reliant digital India, but more so a self-reliant mechanism of running applications for our customers or for ourselves. So that's really all I had for today. You could really go and check out M for Coding via the link over here, and you could try it out for yourself at 9 rupees an hour. And Candice, if I have time, I'd like to probably just dive in and show a quick demo of what that looks like uh, today.
Absolutely.
Great. So just give me a second as I do that. Right. So without taking a lot of everyone's time, what I have here is a first look on M for Coding. I'm within VS Code, quite a lot of our IDs of choice. And I could show you a lot of things happening here. I could probably build a website. I could probably write a few APIs and make a few database updates. But yeah, I hope that for the audience that we have today, I'm able to sort of communicate that picture and share it with you. So the idea is that M for Coding allows you to sort of program in about 499 programming languages, really everything that comes under the sun and moon that we would be using on a day-to-day basis, and it allows you to plan and take actions. And this is again a very very solid theme that we've seen in open source when it comes to coding agents. So within plan mode, we could send in a request. And what I'm trying to do over here is I'm trying to optimize my wave to lip module. For those of you who might not be aware, this is something that allows you to take a video and then add lip syncing capabilities as we work on a translation pipeline. So we are working on a very similar tangent for a government ministry wherein they want to take videos that were recorded in a certain language and then translate them to another language, but also enable the orator within these videos to lip sync in the new language, right? So a small snippet of code from that where I'm trying to optimize a small challenge that I'm facing in terms of resolution. And you can see that, very quickly, it's gone through all the hyperparameters we have at hand. I'd also like to push your attention to the inferencing time and, the overall time that it took to give that result. Uh, Hundreds of users are already using M for coding. So this is taking into account that there is a lot of concurrency that we're handling internally within the organization as well. And it's giving me a few ideas wherein, it's telling me that, we could probably optimize a few hyperparameters along melt step size. And it's telling me that it's going to help me get better accuracy, right? So if I just sort of move over to act mode without even giving it instructions, it's going to start making the changes that it really gave me. And you can see that autonomous coding experience that we have at hand. And, it's also going to look at any other considerations. So we had a hard coded value that it wants to remove, and that's what it's doing. I've kept control within sort of my hands over here, wherein I've disabled automatic read and edits, and that's why I'm having to click save. But if I do that, then it's really going to go ahead and do everything on its own. So the ideal experience that you'd want when you're coding, especially with large context, uh, that's the point I'm trying to make. That we're already there. The economics work. The models are great in terms of planning and execution and documentation and analysis. And it's giving me a README for the changes that it's done as well. And this, for those of you who might already be using proprietary tools, is an experience that you really probably started getting just a few months ago, and open source is at par with it already. So I really encourage all of you to give it a shot within the confines of your own organization or within your own projects, and really see what open source is capable of doing. At NextGen, it's a statement for us. We're going to continuously keep updating the products that we have, including M4 with the latest and greatest in terms of the model families, in terms of accelerators, and we're going to make sure that we're on top of that open source journey, on top of the open source curve at all points in time. So that's a commitment that we've made as an organization, but really it's something for all of you to consider. So this is going to continue sort of making its fixes, probably another second, and then it's going to tell us that we're good. But yeah, that's what I had it, to show to all of you, to share with all of you, and I'm happy to take a few questions. Great. So I do have a few questions in the Q&A section. So Candice, should I go ahead with them? Is that all right?
Yep, you can go ahead and just answer the questions, and you got about 10 minutes left.
Great. Perfect. As planned. So we have a question based on your experience. How long can we possibly take for a company to, let's say, review all of these points, define the AI transformation charter? So I'm going to take that first, right? Because it might seem like a lot. Uh, First time always takes a lot of time, right? Every time we do something, we're trying to discover certain aspects for the first time. That could be a time-consuming experience. But I think the motivation behind webinars like this, or let's say, if we were to get into an engagement as an organization with your organization or with you as an individual entity, uh, we don't really have to reinvent the wheel over here. Quite a lot of the considerations that I've shared on this call will apply as is and can significantly drop the time that you would take to experience, experiment and move on. So if you were to set up, hypothetically speaking, if you were to take infrastructure, orchestration, model family, inferencing, coding agents, everything into account, and you were to work, let's say like a startup, I would say that you could make your transformation uh, within a month. I think that you could have a version of a fully sovereign coding agent running, within your organization. Uh, I think within a month, and that is, saying something. Uh, and this is because every time we've put in effort into doing something new, the first time could take probably 6 7 months. But then with the learnings that we have today, that we're so happy to share, and with the open source community really prescribing blueprints across all of these tangents, that journey is a ridiculously small journey. There's also a question about, and this is a very famous question. What's your opinion about the percentage of developers that might be replaced by AI coding agents? Uh, so I'm not sure if you've heard Jensen Huang's take on this, but I'm just going to quote him. I don't think that we're going to be replacing developers. Jensen's statement was, people who are using AI coding agents will replace people who aren't using them. But I have a small take on that. I feel that you'd want to enable your developers to use these agents wisely and increase the work rate. And just bear with me as I try and explain that. Uh, you want to make sure that your developers are doing more in the same amount of time, and therefore that is much more valuable for me as a metric than the cost that I might be saving by letting them go. And if I'm able to sort of take a developer's 8 hour window in terms of bandwidth and push out, you know, 5 products in 6 months, might be significantly more beneficial for me than to just let them go and save their salary amount as a token. And the more I communicate with the leadership within NextGen or quite a lot of the other leadership teams across different organizations, I don't think anyone is trying to optimize cost by letting 5, 10, 20, 30 developers go. They're just trying to make sure that we have optimal work rates, and we're best leveraging the time that we are paying developers for. So that's my take on it. I hope I've answered that question. There's a question about the efficiency aspect, right? The carbon footprint with accelerators and with the energy that they consume. So firstly, I mean, when you look at I think infrastructure as a space altogether, it becomes very important to make sure that your accelerators are running in the right environment, right? So hypothetically, I could have an NVIDIA H200 right next to me over here, sitting in my organization. But then I need to make sure that I am optimally cooling the server. I have to make sure that it has electricity 24/7. I need to make sure that I have backup power systems and UPSs that, make sure that when my main supply goes away, I have some fallbacks. So there is a lot of consideration that really goes behind it. But if you are able to make sure that you're giving your infrastructure the right environment and you're keeping it at the right temperature, you're cooling it the right way, you could make, sort of ensure that your accelerators are not throttling in terms of temperature, and they're not really a burden on the environment as well. With that said, there's also a lot of work that NextGen is doing with respect to liquid cooling optimally. All right, so we are moving from uh, air-cooled solutions to liquid cooling, and NextGen is also working with startups in the valley with respect to diamond cooling, which is a very very effective thermal conductor that significantly drops the temperatures of the GPUs, or at least increases its capability in terms of doing more operations per second. So when it comes to dropping carbon footprint, the motivation that the industry is prescribing is more so to do with uh, how much more again can we do for while we are putting in the same units of electricity, how much more can we do from the same accelerator, thereby reducing the overall number of accelerators that we might need for a specific use case. So there's another question. As compared to Cursor and similar products, how is M4 more sovereign? And also, is there a free trial version? So Hans, happy to discuss this, ahead with respect to getting you maybe a sandbox where you can try it out. But the way we look at M4 coding, so there's two ways to consume it, right? Quite a lot of our customers are running M for coding as an application altogether on their infrastructure entirely. Now, this is to do with the models, this is to do with the extension itself. They're taking the entire solution and trying to sort of retrofit it on their own infrastructure, and then we sort of cut off from that point on. So then it becomes a truly sovereign solution. But we know that a lot of the community, a lot of the customers that we have, not everyone is in a position where they could sort of replicate the entire infrastructure that we are leveraging for M4 coding and then do it on their own set. So we also have a cloud offering wherein the solution runs entirely on our sovereign cloud. And when we say sovereign, whether we're talking about NextGen's public cloud, whether we talk about NextGen's virtual private cloud, or we talk about on-prem setups, NextGen's infrastructure, is heavily compliant with controls and frameworks. We run some of the most critical ministries in our government. So we are sort of backing our public cloud with that confidence as well, that it's heavily compliant and is backed by the ministry in India itself. So we're putting in our best foot forward in terms of making sure that all options are available for our customers. This could be them wanting to run M4 coding entirely on their infrastructure, which is a great value prop. No one else is allowing you to run probably a version of Cursor or a version of Cloud Code on your own infra. But beyond that, making sure that whatever aspects we do run on our cloud run on a heavily compliant cloud, and that's our motivation. So I think we don't have any other questions. The few others have been answered live. So I think Candice, you can take over, and thank you so much.
Perfect. Thank you so much, Abhishek, for your time today. And thank you, everyone, for joining us. As a reminder, this recording will be on the Linux Foundation's YouTube page later today. We hope you join us for future webinars and have a wonderful day.